Hello everyone, hope everyone is doing great. Welcome back to my channel Build with Swinder. As part of this video series, today we will be building the logic for this lead code problem 100, which is same tree. In this, we are given two trees. We have to find if they are same or not. And what does this same means? The same means they should be identically same, like structurally they should be same. Let's say here we have one node and it has two children. Similarly, here we have one node and it has two children. So this tree and this tree, they are structurally identical. And also we need to check that all the nodes should have the same value at the same places. So let's say this is a root node. These two values are same. Okay. This two is same. Three is same. If all these conditions hold, then that tree are identical. So let's say if this is a tree given to you and there is another tree, this, and now you need to check if these two trees are identical or not. First, they look structurally identical because here we have the root node, here we have the root node. It has two children. This tree also has two children. So they are structurally identical. But if you notice the nodes at this position and this position, they don't have the same values. So they are not the same trees. How can you solve this problem? Generally, for tree-based problems, there are two solutions. For most of the problems, BFS and DFS. I'll show you how to solve this problem using DFS because DFS is more intuitive. Okay, so here I'll use the same problem which is given to us and I'll show you how to solve it using DFS. Initially, you have a pointer which is the at the root node. So this is P and this is Q. If you remember in my previous video, I told you that to solve tree-based problems using DFS, you don't have to think too deep what's gonna happen inside the recursion initially. You just have to think greedily, like what will happen if you have a tree which is rooted at this index and another tree at this index. You don't have to think too deep initially, and then you just come up with the base cases, like what's your base case. So let's say there is a function is same tree whose return type is boolean. Okay, so this is the function for which we need to write the implementation, and it has two parameters as input. This is the root node for first tree, and this is the root node for the second tree. So if you remember, there will be a base cases here. I'll just write these base cases later. Okay, so here I'll write the base cases later, but for the timing, let's assume that we have the base cases. So now let's say if we are standing here at this index and this index, how can I say that my root or my tree rooted at P root node and my tree rooted at Q node is similar? How can I say that? Can I say that, let's say if the left part of this P and the left part of this Q is same, and if the right part of this root node and the right part of this root node is same, and if these values are equal, then the trees are same. Or can I say that? Okay. Again, what I'm trying to say is, if I'm standing at this node for the first tree, if I'm standing at this node for the second tree, when can I say that these two trees are equal? When the left part is same, right part is same, and the value as these indexes is the same, or the value at these nodes is the same. If yes, then my tree is same, otherwise it's not the same. So let's say somehow I have the answer for my left part. Okay, so here I'll have one boolean, which is left subtree similar. Okay, so I'll just call the same function is same tree by calling the left part for the P node and by calling the left part for the Q node. You just have to have faith in the recursion that it's gonna work. Then it will be easy for you to understand. So now you have assumed that you have answer for your is left subtree similar. Similarly, you will have another boolean is right subtree similar. Okay, and you will call the same function but with the right part for the P node and the right part for the Q node. Now, if you know that your left tree is similar and your right tree is similar, then you all what you need to do is you just have to check if P dot val is equal to Q dot val. Val is basically the value stored at those particular nodes. And now see what you have to check is these two values has to be same and the left part should be similar and the right subtree should be similar to the right subtree. So you just have to check if these p-val, q-val are same and is left subtree similar and you have to check is right subtree similar. If you if this is true, then you have to return true. Otherwise, if any of this is false, you just have to return the false. Now let's come back to the base cases. What should be the base cases here? See, for P and Q, there could be it could be possible that P or Q is null, right? So I'll just write the first base case. If P and Q both are null, can I say that they are same? So let's say if both trees are empty, then it means they are similar, right? So I could just return true in that case. And similarly, if either of them is null, so if both of them are null, I know the answer is true. But if one of them is null, they can't be true, right? So let's say I'm given two trees. The first tree is this, and the other tree is empty. So P node is this, and Q is null. So in that case, I just have to return false because the trees can't be the same, right? So this will be the base cases, these two, and this would be the core logic to return to check if the trees are similar or not. If you notice, what should be the time complexity of this particular solution? I'm just traversing each node once, and let's say there are total n nodes. So the time complexity would be O of n, and the space complexity would be O of h, where h is the height of the tree, which comes into picture when we use stack to go deep inside the recursion. So this will be the space complexity. Now I can show you the same problem on Leetcode, and we can see if what's the solution for this. So here's the problem on the Leetcode. Here I'll write the same cases. I'll check the base case. I'll write the base cases first. If P is equal to null and Q is equal to null, if both are null, I know my trees are same basically. If both of them are null. Else, I'll check if either P is equal to null or Q is null. So let's say if one of them is null, then I know the answer is false. Now, what I need to do is I need to check is left sub tree is same, or I'd say is left subtree same. Here I just need to check for the left subtree of the P and the left subtree of the Q. Similarly, I'll have to check if right subtree is same or not. So now I'll have to pass the right node for the P and the right node for the Q. Then in the end, I just need to check if P val is equal to Q val because we have to check that the nodes they should have the same value. If this is true and the left subtree is same and is right subtree same. If these three conditions are true, then we know that our answer is should be true. So we just return true. If one of these three is false, then we just return the false and the recursion will work. So you just have to trust the recursion. You don't have to think too deep inside the recursion. First, you have to think what should be the answer standing on a particular node, which is your core logic. Then you have to think of the base cases. Okay. Now I'll try to submit this code. Let's see if it works. Yeah, so if you see, it beats 100% as this is an ON solution. I hope you guys understood the problem and the solution. And if you do, then please like this video and subscribe to my YouTube channel. I'll be posting more such videos. See you guys in the next video.